Dear students, today we'll continue our practice on mathematics and we'll talk about combination theory and Newton binomial. Here we'll give definitions of types of elements of combination theory. They are shifts, placements, and combinations. Then we'll talk about Newton binomial coefficients, Pascal's triangle and properties of binomial coefficients. The general term connections will call three types of the combination made of some number of various elements belonging to the same set. For example, here, letters of the alphabet, the book in library, cars on the parking, etc. So the first type is shifts. We'll take n of various elements, a1, a2, and an. We will rearrange them in all possible ways, keeping their quantity and changing only an order of their arrangement. So here we'll change only order of their arrangement. Each of the combinations received thus is called as shift. All number of shifts from n of elements is defined by Pn, index n. This number is equal to multiplication of all integers from 1 to n. This is definition of shifts. So shortly we'll write Pn as multiplication of all integers from 1 to n, and we denote it with the symbol this symbol, and it's called n factorial. N factorial. Example. First example. Find number of shifts of the three elements a, b, c. So here the number of shifts, we said it is Pn and this is n factorial. So here how many elements we have? 3 elements we have. So it means this is 3 factorial. Yes. So P3, it's just 3 factorial. Or it is 1, 2, 3. It equals to 6. So it means we have 6 shifts. They are A, B, C, first one, A, C, B, and B, A, C. Then B, C, A, C, A, B, and C, B, A. All possible ways to change order of these 3 letters. Example number 2. In how many ways can 7 students be placed in 7 desks so that all the desks are occupied? So it's also shift. 7 students we have and 7 desks we have. So we need to change their order, their place, but not quantity. Yes. So here we have just 7 factorial, and it's equals to 5040. So this how many ways we have? So we have 5040 ways to place our students, 7 students. So the next element is placement, we call. We will make groups of m of various elements taken from the set consisting of n elements, having these m of the taken elements in various order. The received combinations are called as placements from n of m, and we'll denote it by a index n and the power m. So it means it's equals to multiplication n minus 1 n minus 2 till n minus m minus 1. So one more time, placement. So here we'll make groups of m of various elements taken from the set consisting of n elements, and having this m of the taken elements in various order. Again, we'll change their order. Let's consider the next example. Find the number of placement of the 4 elements A, B, C, D on 2. So here the number of elements here 4, and we need to take only 2. So it means n is 4, m is 2. So it will be A 4 2. And how to find it? So it is equals to A 4 2, it's equals to. So here 4, then the next one is 4 minus 1, it is 3, yes? And here we have the last one should be n minus 1, so it means 4 minus 2 minus 1, it's just 1. So it means this is equals to 3. So we'll continue till 3 just, yes? So it's equals to 12. And these placements are, so on 2 here, yes? We need to make groups with 2 elements, AB, BA, AC. Yeah, we have this kind of 12 variants of these placements. And now, let's consider the next example. How many phone numbers of 6 digits can be formed if the digit participates in the phone number only once? So how many digits we have? We have 10 digits, yes? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to take here groups with how many digits? 6 digits. So this is again A. So here we have 10 digits. From 10 digits, 6 we need to take. A, 10, 6. This is placement. So, and it's equals to this number, 10 times 9 times, because n minus n minus 1, 10 minus 6 minus 1, it is 5. 10 minus 5, this is 5. So we need to continue here till 5. This is, yes, correct. So it's equals to this number, 151,200. 100,000. So 151,200. This is placement. Okay, and the next element, this is combination. So here we will make groups of m of various elements taken from the set consisting of n elements, not in view of an order of arrangement of these m of elements. So here the main difference between placement and combination, this sentence, so not in view of an order of an arrangement of these m of elements, then we will receive combination from n of elements on m and their total design, and we will denote it by this one, or we can do it like C and M. We have many denotion, or just m n in brackets, they are same. So and can be calculated by the formula. This is formula for combination C and M. And from this formula clearly that they are equal, these ones, because if you put here n minus m, we will get same expressions. You can check it by yourself. Okay, here note 0 factorial is 1. 0 factorial is 1. And if it is it's possible to make only one combination of n of elements of n, which supports of all n elements. So because it is combination n of n, and we have here it's equals to, look here, we have this equation, yes, and let's check this equation together. So combination n minus m, so it is equals to n minus m factorial, yes, over, so here we have n minus, n factorial here, sorry, n factorial, firstly n factorial in numerator, and in denominator we have n minus m factorial, and just putting instead of this to this formula, and n minus m, so it means n minus n minus n plus m we will get, yes, factorial. So they are cancelled and we have just n factorial here. So we'll get this formula. That's why we have here C combination n of n, and it's equals to, by this formula, C 0n, and 0 factorial is just 1. And we can use here previous definitions, and total number of combinations can be calculated by this expression. So combination m of n, this is equals to placement over shift. Placement over shift. The next example. To find number of combinations from 5 elements A, B, C, D, E on 3. So here, number of combination. So let me explain one more time here. Placement. So in this case, we have A, B, and B, A. Yes, it can be in placement, but in combination, we cannot use this one. For example, if we have A, B, C, so we don't have C, B, A. Is it clear? So we will use only one time it, because here it's written not in view of an order of an arrangement of these m elements. So that's why we have only one time it is. If you use ABC, if you take ABC, we couldn't take BCA or CBA. So the combination is 3 from 5, and by the formula it is 5 factorial over 3 factorial times 5 minus 3 factorial, and we'll get this answer, it is 10. So this is 10, and so we consider what's factorial. This is multiplication of numbers. For example, 5 factorial, it is till 5, 1, 2, 3, 4, 5. Okay, and this combination, this 10 combination are ABC, ABG, ABE, and ACD, ACE, and AGE, BCG, BCA, BGE, and CGE. So we have 10 combinations of these 3 letters from 5 elements. So one more time, we have 5 elements, A, B, C, D, E, and we need to take a combination of 3 of them, any combination. Okay, now next example, using 10 rows and 8 bearing dollars. So bunches are made that contain 2 rows and 3 bearing. How many bunches of this kind can be formed? So here we can say just 10 um, 10, 10 roses and 8 other. This is also a type of flower. Okay, and we need to make bunches of from consisting from 2 rows and 3 bedding. How can we do it? So let's consider the solution. 2 roses out of 10 we have can be chosen in combination 2 from 10 ways. Yes, this is very easy, obviously. And similarly, we have bedding dollar out of 8. So can be taken in this combination 3 from 8. So we have 3 bedding and from 8 bedding. We need to take 3 from 8 and 2 roses from 10 roses. And now we need connect them, and our bench should be contain these 2 rows and 3 bedding. So how can we format this one? It is by this formula. So we need to multiply these 2 combinations, combination 2 from 10 and combination 3 from 8. And here we have combination 2 from 10. What is it? It is 10 factorial, yes, times 2 factorial times n minus m. So 10 minus 2, this is 8 factorial. So let me show it. It's equals to, here 10 factorial and 8 factorial we can cancel, because in 8 factorial we have 1, 2, 3 till 8. In 10 factorial we have this 1, 2, 3 till 8, and then 9 times 10. So like this. 8, 9, and 10. Yes. And here we have 2 factorial, this is just 2, and 8 factorial, this is 1, 2, 3, 8. Yes, we can cancel this beginning of this one till 8, and we have just 10 times 9 over 2. It's equals to 545. It's 45. Okay, now similarly we can find this combination of 3 from 8. This is, so 8 factorial times 3 factorial times 5 factorial. Again, we can cancel this 5 factorial with 8 factorial, and we have just other ones, 6, 7, and 8 over 3 factorial. This is 3 factorial is 6. We can cancel them, and we have 56. And when we multiply 56 to 45, we will get this answer 1890. Okay, now next example. There are 12 females and 80 males in a grade 12 class. The principal wishes to meet with a group of 5 students to discuss graduation. First question, how many selections are possible? Second question, how many selections are possible if the group consists of 2 females and 3 males? And the last question, one of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female and 3 males are possible? So the question, is it clear? So there are 12 females and 80 males, and the principal wishes to meet with a group of 5 students. Discuss graduation. How many selections are possible? Firstly, let's consider A1 firstly. So, solution. The question involves choosing 5 students out of 30 because here we have 12 plus 18. It is 30. In this group, the order of selection is unimportant. So, this is combination problem. Use the combination formula, and n is 30 and r is 5 here because we need to make groups with 5 students out of 30. So this is combination. I said we can denote by this one also, and it's equals to n factorial over n minus, here we denote just r, our number, and this is equals to 30 factorial over 30 minus 5 and 5 factorial. And here also you can see we can cancel this 25 factorial with this 25, and we have other ones 5, 4, 3, 2, 1, and after 25 we have 26, 27, 28, 29, and 30. So we can cancel like the possible numbers, and we have this value 142,506. So we have such possible ways of selecting the group of 5 students. This is number of students. One more time, this is number of students in each groups. Okay, now B1. So in B1, how many selections are possible if the group consists of 2 females and 3 males? Now we have exactly type of these groups, type of member of this in these groups. It should be 2 females and 3 males. We have 12 females and 80 males. This is close to with this example with flowers. Okay, so here also we need to find firstly 12 from 12 2 and 3 from 80 and possible ways of students. So, and we need to multiply it together. Okay, here the calculation of this combination, and you can see the answer is 66 times 516. So this is 53,856 ways to select a group of consisting 2 females and 3 males. So it's very huge number, yeah. From 30 students it's also. And third question, one of the female students is named Brooklyn. How many 5-member selections consisting of Brooklyn, 1 other female and 3 males are possible? So here also 2 female and 3 males, but 1 member name is Brooklyn. We need to find this number of ways. So there is one way to select Brooklyn, and there are 11 females remaining. So because we have 12 females in all together, so if one of them is Brooklyn, we have 11 females. Other ones, yeah. So there are combination. So C other combination it is C 1 from 11 now, not 12, because we need to put this. We had to put this Brooklyn for each groups. That's why we cannot take this Brooklyn. We cannot choose this Brooklyn for the second female. That's why we have this is we by this way we can choose the second female. We can choose the second female. So it's combination of C y. This question why is C 1 of 11? This is 11. It's very easy to check. C 1 11. Sorry. So it is 11 factorial over 1 factorial, yes, times 10 factorial. So 11 factorial over 10 factorial, this is just 11. Okay, now, and then we need to select 3 males. So this is, we did it. So it is C, combination 3 from 18. And how many? So now we need to multiply all of them. So the one is Brooklyn, then 11 ways, this is the second female, and this ways it is 3 males. So we have how many? 8. If we compute them, we have 8,976 ways to select these 5-member groups, which contain Brooklyn. Okay, the next section it is combination with cases. Let's consider this example. Rihanna is writing a geography exam. The instructions say that she must answer a specified number of questions from each section. How many different selections of questions are possible if? First question. She must answer 2 of the 4 questions in part A and 3 of the 5 questions in part B. And second one, she must answer 2 of the 4 questions in part A and at least 4 of the 5 questions in part B. Okay, let's try to solve this problem. Okay, first question, she must answer, the instructions say that she must answer a specified number of questions from each section. How many different selections of questions are possible if? First one, she must answer 2 of the 4 questions in part A and 3 of the 5 questions in part B. So let's do it. This is the number of ways of selecting 2 questions in part A. It is combination 2 from 4. And the number of ways of selecting 3 questions in part B, it is combination 3 of 5. And now we need to multiply these 2 values of this combination, and we'll get 60 different ways in which Rihanna can choose 2 of 3 questions in part A and 3 of 5 questions in part B. I think it's clear. And the B1, at least 4 It means that Rihanna can answer either 4 questions or 5 questions in part B. And solve the problem using 2 cases. First case, answering 4 questions in part B. So this is part A choices, and this one is part B choice because this is 4 from 5. And the number of ways of choosing this question is the multiplication of 2 of them. It is 6 times 5. It's 30. So she has 30 ways of choosing these questions. And case 2, answering 5 questions in part B. So we'll consider all possible cases. And it's again combination 2 from 4 and now 5 from 5. And it's equals to 1. Yes? And we have 6 times 1. It is just 6. So we have 30 and 6. And now each case represents an exclusive or separate event. The final answer is the sum of both cases. So we need to add them. 30 plus 6, this is 36. So we have 36 possible ways to answer 4 questions in part A and at least 4 of 5 questions in part B. So 2 of 4 questions in part A and at least 4 of the 5 questions in part B. This is combination. So I think we considered enough examples, and at the end I will give you some examples to as homework, and try to do them by yourself. So now we'll move to the next section, Newton binomial. So what's Newton binomial? We started short multiplication formulas. Here we have, for example, a plus b squared or a minus b squared. Yes, and we know it's equals to a squared plus 2ab plus b squared. And now here we will start a more complete case, Newton binomial. It is a formula representing expression a plus b n's power at positive whole n in the form of polynomial. So it's equals to a n's power. Look here. Now, why we need this combination, placement, shifts? Now we'll use this combination. And we'll get this formula to find a plus b n's power. So, and here we'll note that the sum of indicators of degrees for a and b is constant and is equal to n. Look here, n minus 1 times 1. It means n minus 1 plus 1, so it is just n. So here the same, n minus 2, 2, etc. Yes? If we open, for example, a plus b cubed, we know this is a cubed plus 3a squared b plus 3ab squared. Here, if we want to write with combination, and it will be 3, I mean, combination 3 of 2. So it is 3 factorial over 1 factorial times 2 factorials. It's equals to 3 here, yes? So it will be 3ab squared. Look here. Here also the degrees are, the sum of degrees are 3. 2 plus 1. Here also 1 plus 2. And the answer is a cubed plus 3a squared b, 3ab squared, and plus b cubed. Numbers, these combinations, yeah. are called binomial coefficients, and they can be found applying only addition of to use the following scheme. In the uh, top line we write 2 units, so or and all next lines begin and come to an end with units. So indeterminate numbers, these lines turn out summation of the next numbers from the last line. The scheme is called as Pascal's triangle. So look here, we have 2 1s, and then it's begin with 1, and we will add the previous one, 1 plus 1. In the middle, what we have, it is 2 and 1. And here also we'll begin with 1. 1 plus 2, it is 3. 2 plus 1, it's also 3. And 1 again. So, and 1 plus 3, it is 4. 3 plus 3, it is 6. 3 plus 1, it is 4. This is 4, and is 4. So, this case for n is 4, for example, this one. So, it is a plus b 4's power. And the next one, for 5, it is 1. 1 plus 4, it gives to us 5. 4 plus 6, this is equals to 10. And 6 plus 4, it's equals to 10 again. And 4 plus 5, it's equals to 5. And etc. So we can see here, for n is 8, we can write with using the Pascal's triangle, the coefficient of our binomial. And what does it mean? So here it means, for example, if we want to write for n5, so a plus b fifth power, yeah, so it's equals to, so first coefficient is 1, so it means a fifth power, then plus the next coefficient is 5, the next one is 5, and now look here, so a 4, so minus 1, and b, they are decreased, b is increased beginning from 1, plus the next coefficient is 10, so it means 10, and the next one is a is 3, b is squared, so the sum of powers should be 5, and plus the next one is also 10, 10 a squared and b cubed, and plus the next one is 5, 5 a b fourth degree, and the last one is 1, so it is b fifth power. So by this way we can open any others. So this scheme we call Pascal's triangle. So here also it's written the result of a plus b 7th power. Okay, now properties of binomial coefficients. First property, sum of coefficients of decomposition is equal to the power of n. So sum of coefficients here is written. For the proof, it's enough to put instead of a and b 1, so 1 plus 1 n's power, so it is 2 n's power. Second property, its coefficients of the members are equidistant from the ends of decomposition are equal. This property follows from a ratio, so this is equal. It means this equidistant, it means, for example, 4 4 or 5 5 6 6 15 15, yes, they are equidistant, so equal distant. Next property, the sum of coefficients of even members of decomposition is equal to the sum of coefficient of odd members of the decomposition, and each of them is equal to the power of n minus 1. And for the proof, we will use a binomial. Here, even members have a sign plus and the odd minus. As a result of the composition, it turns out 0, then the sum of their binomial coefficients are equal among themselves. Therefore, each of them is equal to 2n minus 1. And now let's consider the next example. The first three terms in the binomial expansion of 1 plus e to the power of x n's power are this one. Find the value of n and the value of e. So look here, this is three terms in this binomial. And now, solution. We need to find n and e. The first three terms are with combination. It is c0 from n, c1 from n, and this ax, because the first term it is 1. So the next one is c2n ax squared, yes? And let's open it. So it will be 1. This one is equals to 1. Then this is equals to n times ax. Then it's equals to n minus 1 over 2 a squared x squared. Now comparing this like terms, we'll get the following identity. So it is this one equals to the given one. So here n a it is 2. We have simultaneous of equation, and this n minus 1 over 2 a squared equals to 5 over 3. We have two variables n and a and two equations. After solving this system of equation, we'll find the value of parameters. N is 6 and a is 1 over 3. This is answer of our example. Next example. Find the coefficient of x cubed in this product. Yes. So here we have fifth power. So we need to open this fifth power. We can use here Pascal's triangle or combination elements, yes. And we have this one. So here we need to find the coefficient of x cubed. That's why we didn't need we don't need other terms with x fourth power and x fifth power. Yes, here we will get this 4 and 5, but we don't need them because we need to find just coefficient of x cubed. So here we need only 0 power, first power, second power, and third power. So they are equal to this expression. And now let's multiply. So 1 times find the coefficient of x cubed. Yeah, here. So it is when we will get x cubed, when this 80 x cubed times 1, so it's minus 80, and 40 x squared times this x. Yes, we need to multiply this one, this bracket, to this one. So when we get them, so let me write here 1 plus x plus 2x squared. Yes, so here if we multiply this 80x cubed to 1, we get x cubed, And when we multiply 40x squared to x, we'll get x cubed. And 2x squared to minus 10x, we'll get x cubed. So the coefficients of x cubed is minus 80 plus 40. We'll add them. And minus 20. This is minus 60. The final answer is minus 60. The next example. Find the constant term in the expansion of x squared minus 6 over x and power. Constant term. What does it mean, constant term? It means without any variable. In our case, our variable is x. It should be just number. So in the expansion of this expression, the r plus first term is so it's equals to 6 the combination r from 6 times x squared, 6 minus r power and times minus 2 over x. This is r plus first term because look here, this is n, yes, and when we will take r plus first term, should be this one in r power, and here we have x squared also. Okay, let's compute it, and we'll get here this one. Yes, so the answer is this is okay. For the constant term, the power of x is 0. So firstly, we need to find in generally any r plus first term, and then we'll find this, we'll equate this power to 0, and we have r is 4. So then the constant term, the coefficient of this term will be now combination 4 from 6 minus 2 the power of 4. After simplifying, we will get this one, yeah, and it is 15 times 16 or 240. Or here we can find by other way. For example, this is x squared, this is x, yes, and when they are cancelled, when for example they have same powers, yes, so when can be it is so if we take first one, it is just x, so I mean here this we get here 4, yes, so it means this in this case, if we consider here so fourth term they will cancel. Find the maximum, next example, find the maximum coefficient in the expansion 3x plus 5 tens power without actual expansion. Note that the r plus first term in the expansion is r plus first term. Here we have 3x plus 5 So in the previous example we have some mistake here, not and it is just 6 and it's just 2. So when we give example, so it's also 2 and it's just 6. I didn't pay attention to this power. This is not n, this is 6 power. When it's 6 power we can find. So and then this equation is satisfied. Please correct this example. Okay, now next example we have r plus first term in the expansion is this one. So combination r from 10 because of 10's power 3x r and 5 10 minus r power. Yeah, and now we consider the ratio of r plus second term to r plus first term. It means r plus second term we will get this one, and when we divide them we have 3 over 5, they are cancelled, and 10 minus r over r plus 1. So to see which coefficient is maximum, we only need to know when the ratio is greater than 1 and when it's smaller than 1. So when it's greater than 1, where r is greater than 25 over 8. Therefore, the coefficient increase at first and reach maximum when the integer part here is, I mean, the next integer number, it is 4. So now you need to find this next integer number. So it is 4. The coefficient increase at first and reach a maximum when r is 4, it means. So the maximum coefficient is here, just we need to put 4 instead of r, and we'll get this number. So this is maximum coefficient in this expansion. Okay, now the next example, solve the equation. So here combination, yeah, 1 from x, 2 from x, 3 from x, and this is very easy. Just find the values with x and solve the equation here. You can check it by yourself. Here just we will use the definition of combination, and we'll get here x is 2 and x is 7. So here some exercise to for you as homework. Try to do this exercise by yourself, and the exercise on combinations and Newton binomial. For example, then if let's consider this number 6, determine the number of 8-letter word that can be formed from the letters of the word altruism. Yeah, so you need to find 8-letter word that can be formed from these letters. How many letters we have here? We have 8 letters, but we need to find this ways, how many ways we have. Yes, consisting from these letters only. Very interesting examples we have here. And here we have examples on binomial theorem, and we need to expand each of the following. Here are the examples. So such kind of examples will be in your final exam also. And here, as it is solved equation. That's all. So that's all for today. And if you have any questions, you can write in forum in Moodle, um, where you have the section question and answers. So there you can write your questions. Thank you for attention.